continuity of the composite function. Understand? Continuity of composite function. Understand? Let f and g be two functions such that GOF is defined. We already know for GOF to be defined, we know already, let's say function f is from a to b, okay, and function g is from b to c. So can I define GOF? Yes or no? Let function f is from a to b, then function g is from b to c, then we can define GOF, yes or no? So we are saying the function f and g are defined in such a way that GOF exists, okay? Then GOF will be discontinuous at points now in the function GOF, the function f is basically the input for GOF, yes or no? If we see GOF, GOF is nothing but g of f of x or not, yes or no? So GOF is nothing but where function f of x is the input for the function g, yes or no? So if function f of x is discontinuous, then GOF, the composite function GOF will become discontinuous, okay? So whenever you are looking at discontinuity of your GOF, so first point is those points where f of x is discontinuous. F of x is discontinuous. All those points where f of x is continuous, GOF will also be discontinuous, okay? Because input itself is not defined, okay? Second, where functional equation of GOF is discontinuous, okay? Two things that you have to consider. First thing, f of x, all those points where f of x is discontinuous, GOF will be discontinuous without any doubt. Now, you will be calculating GOF equation, yes or no? You will be calculating your GOF equation. So GOF equation, wherever it is discontinuous, this GOF is discontinuous. So these 2 points you have to consider while talking about the continuity of the composite function GOF, okay? F of x, wherever it is discontinuous, composite will be discontinuous. And finally those points at which your functional equation of GOF is discontinuous, okay? Now let's see using some examples. Somebody staying there? Why? No, get out. First of all, you will not stand here. Just, I don't care. I'm asking you. I'm calling your parents. No. Just go outside. The first time you are making mistake? Are you making first time mistake? Every day you are making mistake. You are just sitting like a stupid in class. Every day I see your face and you are studying nothing. Don't I know? No, just get out. Call his parents. Call his parents. With examples, we will understand. Let's say, question is f of x equal to 1 over 1 minus x. Okay, 1 over 1 minus x, and the question asks discuss continuity of x. Continuity of x. Okay, it is also what? It is also a composite function or not? It is also a composite function. So again we will apply these 2 points. First point, f is discontinuous at x equal to 1. We already know this because f of x is not defined at x equal to 1. Yes or no? X equals to 1 function is not defined. That means it is discontinuous. If f of x is discontinuous at x equals to 1, f will also be. Okay? Second, we will calculate functional equation of the composite function f. Okay? So f of x is nothing but f of fx. So f of 1 over 1 minus x. Yes or no? You can directly write from here also. Now f of x is what? 1 over 1 minus x. Yes or no? And in this equation, this whole f of x is the input. Yes or no? In place of x, what we have? F of x. So here, wherever I am getting x, I will replace it with f of x. So 1 over 1 minus f of x. Can I write this? Now put the value of f of x now. Do you understand? Now put the value of f of x, that is 1 over 1 minus 1 over 1 minus x. Quickly calculate and tell me what we are getting. One minus x by x. So we are getting 1 minus x divided by x. Okay? X minus 1 by x. Now tell me this functional equation of the composite function f. It is basically x minus 1 by x. Okay? Now it is discontinuous at what point? X equal to 0. You have denominator 0, x. So it will become 0 at x equal to 0 or not? How can you say x minus 1? X minus 1, it is not discontinuous, it is continuous everywhere. Yes or no? So f is discontinuous at x equal to 0. So combining these two, x equal to 0 and 1 are points of discontinuity. Okay? Points of discontinuity. Okay? Now we can check what kind of discontinuities we are given. We already know this composite function f has two discontinuities at x equal to 0 and x equals to 1. Yes or no? So the continuity of the composite function, that is the only thing. Very, very easy. Now if you want to calculate what kind of discontinuities we have, we can calculate that also. Discontinuities, we have talked about it. Removable, non-removable. In removable we have missing point, isolated, non-removable, finite, infinite and oscillatory. Okay? So let's say type of discontinuity I want to calculate, just for the sake of calculating. If I see, then at x equal to 0, at x equal to 0, if I calculate, let's say, left hand limit, first of all I will check whether limit exists or not. That is the only criteria to check whether it is removable or non-removable. So left hand limit is basically limit h tends to 0 of 0 minus h. Yes or no? Now I have, whenever you check what kind of discontinuities we have, so you will check using the final functional equation of the composite function. Okay? You have of x minus 1 by x. Yes or no? So if you calculate, then this will be minus h minus 1 by minus h. Yes or no? As h tends to 0, minus h is becoming 0. Numerator we have minus 1. Denominator we have minus in minus. So 1 by h we are getting ultimately. As h tends to 0, total value is tending to positive infinity. Yes or no? As h tends to 0, minus h is becoming 0. Yes or no? Negative sign we have in the numerator. Denominator also we have negative sign. Cancelled out. 1 by h tends to positive infinity. That means it is what? Infinite type. At x equal to 0, we have infinite type. We don't even really need to calculate right hand limit. Yes or no? Now, at x equal to 1, left hand limit if I calculate, then limit h tends to 0, 1 minus h. One minus h minus 1 divided by 1 minus h. So 1 and 1 gets cancelled out. Minus h divided by 1 minus h. H tends to 0. Numerator is tending to 0. Denominator is tending to 1. Okay. So the whole value tends to 0. Right hand limit will also come out to be 0. So limit does exist. Okay. Limit does exist. That means it is removable. Yes or no? It is removable. If it is removable, then which type do we have? Missing point or isolated? Array, at isolated, your value of the function, okay, at exact point exists, is defined, but not equal to the limit. Now if you see, at x equals to 1, f of x is not defined. Okay. If it is not defined, then it is missing point discontinuity. Missing point discontinuity. Now understand, the purpose of removable and non-removable is by adjusting something we can make our function continuous. Okay, by adjusting something we can make our function continuous. Okay, so f of x, if I redefine, it is equals to x minus 1 divided by x when x is not equal to 0 or 1. Okay, when x is not equal to 0 or 1. Now at x equal to 0, it is your non-removable type infinite discontinuity. Yes or no? So at x equal to 0, I cannot do anything. But at x equals to 1, the only thing that I need to change is exact value of the function at that point. Yes or no? And if limit exists, left hand limit, right hand limit, and the value of the function must be same. So at x equal to 0, x equals to 1, limit is 0. Yes or no? So if it is your removable, then I can redefine the function in such a way that function becomes continuous at x equals to 1. Yes or no? Do we agree? What we are doing here, we are basically redefining function in such a way that our function becomes continuous, but only at those points where discontinuity was removable. Non-removable, you cannot do anything because we already discussed for non-removable, your limit does not exist. If you do something, then you have to change your whole function, isn't it? But in the case of removable, limit does exist. Only you need to do is redefine the exact value of the function. Just by redefining the exact value of the function equal to the limit of that function, it becomes continuous. Yes or no? That's what we did. Here we had missing point. How did we make it continuous at x equals to 1? By redefining value of the function at x equals to 1 equal to the value of the limit. Is it clear? Quickly copy. So our fog or GOF, 2 points we are checking wherever your input function f. Okay, the first point is your input function we are talking about, yes or no? And the second is where the final functional equation is discontinuous. At those 2 points, your function will become discontinuous. At all other points, it will be continuous. Raghu sir, चाय, एक चाय और पानी. Are we done?
ना अभी नहीं भेजेगा. मेरी क्लास में वो तब तक नहीं बैठता जब तक पेरेंट्स नहीं आते. सुबह आते हैं तो उसके पेरेंट्स से बात करके हम क्लास में बिठवाते हैं, वरना हम नहीं बिठवाते उसको. ठीक है सर. अरे वो बच्चा पूरे जितना भी 4 महीना टाइम पूरा बर्बाद किया क्लास में बैठ के, कुछ नहीं पढ़ा वो. जब तक पेरेंट्स को नहीं बुलाते तब तक काम नहीं होता सर. नहीं 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 नहीं, यहाँ पे रखना ही नहीं है उसको. गेट आउट.
Okay, is it clear? Now understand your composite function. We have defined composite of the 2 function. Can we define composite of the 3 function? Can we define composite of the 3 function? F O G of H. Yes or no? Can we define composite of the 4 function? 5 function, 6 function. Yes or no? Again, the same concept will be applied. Again the same concept will be applied. Let's see. We have checked discontinuity of FOF. Okay. Should I rub this off? Right hand side. Now let's say same question. Same question. Okay. Composite of the three functions. Enjoying? Say it again and I will call you on the board. Okay. The same concept we will apply. Okay. First of all, we saw whenever we are talking about your composite function GOF, then function f of x is basically what? It is basically input for the function g. So we are checking about the discontinuity of the f of x function. Yes or no? Class is getting too much disturbed. Understand this properly, okay? Whenever we are talking about discontinuity of the composite function, focus, discontinuity of the composite function, then our function of x, f of x is the input function of g or not. Now if input function is discontinuous, then we cannot talk about function g, yes or no? Let's say your input function f of x is discontinuous at x equal to 0. Yes or no? That means there is a problem with respect to 0 point. Yes or no? We cannot utilize here. So if we cannot utilize here, then we can utilize x equal to 0 also here. Yes or no? So we are talking about the function f of x itself because it is an input function for the GOF function, g function. Yes or no? And at the end we are talking about the functional equation. We are talking about the functional equation of the complete composite function GOF. Yes or no? Now similarly, if we apply the same concept to FOF, f of x, so if you see, there will be, first condition will be the points f of x is discontinuous. Yes or no? First of all, we will see those points at which f of x is discontinuous, same as before, because we have yes or no? If f of x is not defined for certain values of x, then again their triple composite will also be not defined. Yes or no? Similarly, f of fx is discontinuous because again their triple composite is equals to, yes or no? If f of fx is not defined because it is an input for the f of x function, and without that we cannot define their triple composite. Yes or no? So again, all of the points where f of x is not defined or not continuous will be the points where function triple composite is discontinuous. Is it clear? Third, functional equation of same concept we are applying, yes or no? Same concept we are applying. Yes or no? Now, for this x equals to 1 we have already seen. Yes or no? F of x not defined x equals to 1. It is not continuous at x equals to 1. Yes or no? Now, f of fx we got x minus 1 divided by x. So here x equal to 0. Now we will look at what? Your final composite triple composite function. So this will be equals to no x minus 1 by x. Now f of x is this. So in place of x we have x minus 1 by x. So just replace value of x by this number. So you will get 1 over 1 minus x minus 1 by x. Quickly calculate and tell me what we are getting. No. We will get x directly. Now if you see, normally what happens is that students directly focus on the final equation, final functional equation. If I talk about this is your continuous everywhere, yes or no? If you see, it is continuous everywhere, yes or no? But again, if you see what we have been through, then you will realize x equals to 1 and x equal to 0, it is not continuous, so we cannot even talk about x equals to 1 and 0 for this value, for this function, yes or no? So again, for this triple composite, x equals to 0 and x equals to 1 are basically point of discontinuity. Okay. Now if we check type of discontinuity, then we will see both are missing point or not. Let's say x equal to 0, if I calculate, then the left hand limit and right hand limit is equal to 0. Left hand limit and right hand limit equal to 0 or not. If I check at x equal to 0, left hand limit, right hand limit equals to 0, yes or no? So if I redefine the function such that x equal to 0, the value is 0, then my function will be continuous or not. Similarly, at x equals to 1, x equals to 1, what? Yes or no? So x equal to 0, x equal to 1, because limit does exist, yes or no? Left hand limit, right hand limit does exist. That means we are in the removable section. And x equal to 1, x equal to 0, function is not defined. That means both are missing point. Both are missing point, yes or no? Should I rub this off left hand side? So again, we have found the discontinuity of the triple composite. We have found what kind of discontinuity we have. Now again, we have the task to make it continuous wherever it is possible. Our task is to make it continuous wherever it is possible. Okay? Redefine it is x if x is not equal to 0 or 1, yes or no? Otherwise it is valid, yes or no? At x equal to 0, what was the limit? 0. Left hand limit and right hand limit you will calculate from this side, from this using this function, yes or no? So left hand limit, right hand limit of this function comes out to be 0. So if I want to make it continuous, then at x equal to 0, the value of the function must also be 0 or not. So at x equal to 0, I have made my function continuous, yes or no? Similarly, at x equals to 1, what is the limit? Left hand limit, right hand limit is equals to 1. So I have to redefine my function in such a way that my function becomes continuous. That means the value of the function must always be equals to limit of the function. So this is my redefined function which is continuous everywhere. Copy. Last one. Have you made any mistake? Yeah, yeah. Understand, whenever we talk about type of discontinuity, okay, we will always check using the final functional equation. Okay. Now, in the earlier f of fx at x equal to 0, we had infinite type discontinuity, and how did we calculate? Check. We use the functional equation of or not. Yes or no? X minus 1 by x. As x tends to 0, it was tending to what? Infinity? Minus infinity plus infinity, whatever it was. Okay? But it was tending to infinity, yes or no? Because it was your infinite type, not missing point. Infinite type discontinuity, that means non-removable. Let's say if you redefine that function, can you say at x equal to 0, f of x equal to infinity? No, no. So that's why we could not redefine the function previously, because the discontinuity was infinite type, non-removable. Now here, both the discontinuities are what? Missing point. That means removable. If it is removable, then we will remove. When? So I turn it off what? Let me give you one question. Calculate discontinuity of fog x quickly. Very easy one I have given to you. about fog x is continuous for all values of x, or we have point of discontinuity also. Tell me. X equal to 0 and 1 or only 0? What type of discontinuity we have? Infinite, that is non-removable. That means you cannot redefine function to make it continuous. What about your GOF? Yes, at x equals to 1, x equals to 1 we have discontinuity, finite, infinite. Finite type? Infinite type. Infinite type, no? How many of you are getting infinite type at x equals to 1 in GOF? How many of you are getting finite type? And how many you are not even answering? If you study, if you are true to your preparation, then I'm your best friend. That's the point. But if you make mistake, knowingly make a mistake, some mistakes are okay, you are attempting and you are not able to solve. Those are different mistakes. Okay? That can be corrected. That means that your root can be removed. Remove it. No. When we discuss, the concept is now fully clear. Okay? But those mistakes, like reading in class, not reading in class properly, not taking notes, these are known as conjugated. Okay? So if you are true to your preparation, I'm your best friend. If you are not, then I'm your worst friend. Now if we discuss form X, so form X is a very easy question to understand. Whenever we talk about form X discontinuity, okay, we talk about the discontinuity of the inner function. You know, if you see, just on your page there we have started your composite one. We talked about forward GOF. That's where in the beginning we talked about GOF function, discontinuity of GOF, you know. And the first point we saw is discontinuity of the f of x. Now we are not worried about the symbol, whether it is your GOF or whether it is your form. The point is your inner function. The point one is your inner function discontinuity you are looking at. The GOF, the function f is the inner function, yes or no? Here, which one is your inner function? G of x. Now g of x equal to x plus 1 is continuous everywhere. No, it is continuous everywhere. We don't have to worry about that. Now we will calculate functional equation fog x, so f of dx. That means f of x plus 1. That means x plus 1 divided by 1 minus x plus 1. That means minus of x plus 1 divided by x. So now, obviously it is not defined at x equal to 0. X equal to 0, point of discontinuity. Now if you see, it is your infinite type. As limit h tends to 0, it will tends to minus infinity. So now, minus infinity or positive infinity, both. Do you agree? Left hand limit will tends to positive infinity, right hand limit will tends to negative infinity. So now, so it is your infinite type. We cannot redefine function to make it continuous. Okay. Similarly, if we talk about GOF function, then we will look at f of x discontinuity. You don't know at x equal to 1. Inner function in this case is f. You don't know. So f of x is discontinuous at x equal to 1. So GOF will also be discontinuous at x equal to 1. One discontinuity we have. Then we will calculate of x functional equation no no alright, so it is also discontinuous at x equals to 1 no no it is also discontinuous at x equals to 1 and what type of discontinuity we have finite or infinite removable or non-removable non-removable again it is your infinite type not finite no no as x tends to 1 let's say if I calculate left hand limit then limit x tends to 0 we are talking of 1 minus x I will write so many students are writing 0 minus x we are taking limit whenever in the beginning I talked about limit x tends to a yes or no the left hand limit will be a minus x yes or no right hand limit a plus x the value of a will vary according to the question here we are calculating limit at x equals to 1 so in case of a we will put 1 so 1 minus x so it will be equal to limit x tends to 0 1 over 1 minus x so it will be 1 by x will tends to infinity so it is infinite infinite type discontinuous you know now is it better now I asked you to calculate f of x also so f of what we are getting how many discontinuities at x equals to what okay quickly let's calculate and see f of fx first of all at x equals to 1 we already know because f of x is discontinuous at x equals to 1 now we will calculate the functional equation that means x over 1 minus x that means x over 1 minus x divided by 1 minus x over 1 minus x you know now if I take LCM in the denominator then it will be 1 minus x that means 1 minus 2x you know so it will be x over 1 minus 2x if I take LCM then I have 1 minus 2x and 1 minus x in the division here also 1 minus x is in the division both will get cancelled out so x over 1 minus 2x so it is discontinuous at x equals to what 1 by 2 yes or no so we have two discontinuities first is your x equals to 1 and other is 1 by 2 so if I check x equals to 1 then limit exists and which is equals to at x equals to 1 the limit will be minus 1 if you calculate left hand limit and right hand limit based on this functional equation we will calculate the limit or not so if you see left hand limit equals to right hand limit equals to minus 1 yes or no so it is your what missing point isolated point what it is your removable or not because limit exists so it is your missing point because f of x is not defined at x equals to 1 so it is a missing point yes or no similarly x equal to 1 by 2 if you see limit does not exist yes or no limit does not exist left hand limit will be positive infinity and right hand limit will be negative infinity if you check okay yes or no can I write this Now if I approach x from the left hand side, then x minus 1 by 2 is negative. In the numerator we have negative, positive, and denominator is tending to 0, that means positive infinity. The left hand limit is tending to positive infinity, right hand limit is tending to negative infinity, because as x tends to 1 by 2 from the right hand side, x minus 1 by 2 is positive, and negative sign we already have in the numerator. So that means it will tend to negative infinity. In all, it is a infinite type, non-removable. Now, if I want to redefine the function, then help me. What should I write? X over 1 minus 2x. Everybody help me. Tell me for what values of x? Not equals to? X is not equals to 1 by 2. And 1 also, yes or no? This functional equation, it is not valid for x equals to 1 also, because at x equals to 1, f of x itself is not defined. Yes or no? So we cannot use that functional equation. Now, if I want to make this function continuous wherever it is possible. Now at x equal to 0 it is not possible. At x equals to 1 is it possible? At x equals to 1 by 2 it is not possible. At x equals to 1 is it possible or not? It is missing point, removable. So what do I do? I am redefining the function at x equals to 1. And what should be the value? Minus 1. So if I take left hand limit at x equals to 1, then this definition I will use, yes or no? Right hand limit, this definition I will use, value will come out to be minus 1. Now for the continuity, the exact value must also be minus 1. We have defined for exact value, that is minus 1. Made it continuous. Is it clear? This left hand side, can I rub this off? Quickly. Left hand side, can I rub? next class we will start differentiability. If you don't know how to calculate composite of non-uniform function, okay, then go back to that lecture that we covered. This question I should not be getting, sir. I don't know how to calculate the composite function. In the second case, I'm asking. Okay, this question I should not be facing that I don't know how to calculate composite of the non-uniform because we have already discussed it so many times. If you don't able to recall, you are not able to recall, then go back to that lecture.